Very good evening to all. And this is the video of second video, uh, the on under green steel series. And there'll be a couple of videos to narrate all the experiences, full journey of sustainability and green steel in this series. And hope you enjoyed the first video. Kindly like it if you want to like it, and if you have any comments or any questions, always can connect me through LinkedIn. You can always DM me for the same. So far we have talked about a quick solution of carbon capture into an integrated steel plant, existing steel plant, the where the brownfield projects are in a is difficult, where but somebody wants a very quick solution. This is a solution they have to have this carbon capture. And then but however, this carbon capture is a very costly solution, and it has got although this carbon capture project is sustainable, and sustainable by virtue of the overall economics of the project. However, uh, having said that, before you do the project in the feasibility stage, must do the engineering properly, must do the pre-engineering at least properly, so that you know inputs outputs correctly. Outputs particularly, are you going to methanol route or are you going to ethanol route, is the main thing. Ethanol is a better sustainable product, better market values, and then it has got also a lot of byproducts can comes out, such as proteins. And from ethanol, various ISO grades are there. Through the ISO grades you can produce the further uh, textile products, jet fuels, etc., etc. It's a project by its own. It's a project by its own driving energy. So, but it needs a large capex, and it needs an funding also. Now, this funding, when you see the project is viable based on CO2 credits, this funding can be done through your own country's carbon border management plans and various CO2 funds available, or you can opt for international funds. So for that details, that is bit complex, but those details, if somebody wish to learn, wish to understand, always can DM me on this. Second subject on this green steel series is without carbon capture. Without carbon capture, suppose your current CO2 rating is 2500 kg per ton of product, then what you should do to reduce your carbon load? What are your options there? Your options are, you cannot transform overnight all your carbons into a biological carbon, mean to say that who doesn't have a less emissions or zero emissions. That is maybe technically possible in the laboratory, but not possible in practically. So what you should do? One of the options are, you can buy some green metallics. You cannot improve, if it is a converter, you cannot improve the scrap level in the converter for the technical reasons, for the technological reasons and the constraints. And any integrated steel plant is balanced based on the scrap addition and the scrap generation into their own plant. So it doesn't require, or you doesn't foresee to buy any additional scraps. So so then what are the options you have? Your options are, number one, buy the green HBI. Now, green HBI, where from you buy? There are limited suppliers in Middle East, or in MENA region, or in Russian regions, where you can buy this green HBI, provided the other market economics applies, and other restrictions applies. If you are importing from some country, whether your country allows it or not, so and so forth. Having said the same, suppose if you can imagine you got the green HBI, what do you do with that? What are the options in front of you? You can put that, so your main object in blast furnace to reduce the carbon rate. Your blast furnace is operating between 450 to 550 kgs of total carbon. If you can reduce it, you can reduce it to 100, 130. That includes coal injection, coke injections, coke rates, etc. And these two main carbons primarily. And you have a oxygen there. So what is your options? Your options are, number one, you drive the blast furnace through more pellets. Currently, if you are driving at 65% pellet, you increase by 10%. That is option one. Option two, if you have a green HBI, then you charge the green HBI. You order in that particular size which can be charged. So once you charge the green HBI, which is a semi-reduced iron, that will these two action number one, pellet feed more, and action number two, green HBI will lower down your carbon rate, and substantially it will lower down your carbon rate, and it will increase the oxygen portions in the blast furnace. You need to do a basic engineering for that. You need to adjust your twirl velocity, you adjust your air loads, your wrap movements, and inside process engineering to some extent so that you can do this. Third options are, what if you add hydrogen in the furnace? First question is, what cost of hydrogen you are getting? Today, if you have got a green power, if you got a green power at your site at $2 or even less, then you'll be able to get the hydrogen within $3 per kilo for sure. Whether you go to European technology or Asian technology or any other technologies. Suppose if you get a hydrogen of $3 per kilo or even less price, then the job is easier. Then you can start putting hydrogen, but when you put the hydrogen, there will be draft temperature will go down, which will adjust the draft temperature. You have to adjust the carbon again inside the furnace. So there is a process engineering needs on this. That is a detailed. It's not complicated. I should not say it's not simple. Also, it can be mitigated. And should you have any questions on this, how to do it, always can DM me. I am always available to these. I love technology. I love this technological analysis and cost economics. I can always talk with that. Second thing is that if you have a green HBI, what else you can do? You can also do a brownfield arc furnace inside. Now again the questions of technology comes, what kind of arc furnace you will take? You will take the arc furnace of AC furnace, DC furnace, what size of the furnace, whether you are going for a continuous operation of charging of arc furnace or you are doing a batch charging of arc furnace. Those are the key technological areas you have to address it. Once you have the green HBI with you, you have flexibility, and today's technology goes in that manner. You should go with continuous charging of metallics into arc furnace, and that will lower down your CO2 footprint and other things compared with the other furnaces. Although certain emerging technologies are there with DC furnace, with even AC furnace, with various modules and etc. etc. That's a separate discussion. You can always ask me for those kind of discussions. I am available. Therefore, through this process, if you do it successfully, suppose if you got a molten metal out of green HBI, then you can use this green HBI molten metal, which is very lower CO2 footprint, to mix with the higher CO2 footprint green metal, and you can reduce the carbon load into the complex. Now, this is a continuous journey. From 2500, you cannot achieve 200 kg overnight. So it will take some time, some years, some passion, and the fund. For my next session, next video, I will talk about the two things. One is greenfield planning with what if you have got doing a greenfield planning and you have got two situations. You have got natural gas, you have got hydrogen. You have got second situation like Europe, you don't have any natural gas, you have only hydrogen. So how to run the project, how to define the project, what are the technologies, what are the capex. First is that let us discuss in next video about that process technology for a greenfield projects using DRI electric arc furnace. For integrated steel manufacturers, one of the important key aspect is the pelletizing. Pelletizing CO2, although it is not high, it is lower. It is within 80 kgs levels or 75 kgs level. But depending on the technologies you have, whether you have got a travel grade or you have a grade clean, the CO2 levels are different. CO2 emissions levels are different. So you need to define your process correctly and then to proceed. There are emerging technologies are being talked about hydrogen burners in combustion zones. With all respect, so far the for travel grade furnaces, hydrogen burners is available. This is somewhat proven, but in grade clean it is not proven yet. So it will take some time to achieve that. Second thing is that your important part is that your combustion processes, like if it is electric arc furnace, yes, you can use little hydrogen for shrouding, which you are using for natural gas. You can go to hydrogen for sure, you can go, but it is very low, 1 to 2 meter cube of natural gas equivalent to hydrogen, which is you can just calculate the energy, you will find out that value. Then another reactor which is very critical, it's apparently, which is lime clean. Lime clean, every 2 tons of limestone you charge, it produces 1 ton of CO2. How to capture that CO2? Also, in my earlier video, I talked about carbon capture. Yes, you can capture that gas, but volume of the gas is too big, and its concentration is too low. So you need to clean that exit gas. You have to concentrate back CO2, and you can put it down into your carbon capture also. But this process is a bit complicated. It needs a detailed process engineering to do that. So for these all strategies and our process technologies, we can really talk. We can talk hours and hours on this subject, and I love this subject very much. So thank you. And should you have any comments, kindly connect me through LinkedIn, and kindly I should request that kindly like the video so that it gets some circulations, and it is all free. I mean, I'm not charging anything for that. It's all free for worldwide circulation. So I have got only one objective: the myth regarding green steel should be cleared. Lot of consultants, lot of people are talking about green steel, but unfortunately, the basics of green steel is not clear in the market, and that is required to be clear as early as possible, because in order to achieve our environmental safe and sustainable for not for today but for next generations. Thank you and bye. Thank you and bye.